Section 96A is about perfect squares and factoring. If you think back to Chapter 8, you'll remember that we learned how to multiply a binomial that was squared, and we used a special pattern that looked like this. You remember that we did the square the first term, square the last term, and we take 2 times the first times the last in the middle. Now that pattern that we learned back in Chapter 8, I told you to remember it because now we're going to use that same pattern because that trinomial has a special name. It's called a perfect square trinomial. And if you ever see a perfect square trinomial, now that we're dealing with factoring, you should be able to take that perfect square and pull it apart into its binomial factors just like this. So here's an example that you'll see. Here's a trinomial, and it's a perfect square because the first term is a perfect square. It comes from 2x squared. The last term is a perfect square. It comes from 5 squared. And the middle term is that 2x times 5 times 2. Because remember, the middle term has to be 2 times the first times the last. And if it matches that pattern, if it is a perfect square trinomial, we can immediately go to this step and factor it out into 2 groups, in this case a group that's the same, squared. So here we're going to learn how to recognize the pattern for a perfect square trinomial, and then if we find out that it is, we're going to actually factor it. So here are the questions we have to ask. Number 1, is the first term a perfect square? Well, we know that 16 is a perfect square, and we know that anything with an even exponent is a perfect square, so yes. So what creates a 16x squared? Well, when you square a 4x. So that first term is good. Second step, is the last term a perfect square? 64. Yes, it is. 8 squared is 64. And here's where if you know your perfect square numbers, this is a lot easier. Plus sign goes here, plus sign goes here. Now, does the middle term match the pattern? Is it 2 times 4x times 8? That's the pattern we're looking for. 2 times the first term times the last term. 8 times 4 is 32, times 4 is 64. So in this case, this should be a 64x, but it's not. So we say that we cannot factor this. This is not a perfect square trinomial. Here's the next one to check if it's a perfect square trinomial. Number 1, is the first term a perfect square? Yes, it is. 3y, if you square 3y, you get 9y squared. And the last term is also, if you square 2, plus and a minus this time, minus because there's a minus up there. Now, is the middle term 2 times 3y times 2? That's the question. 2 times 3 is 6, times 2 is 12. Yes, it is. So this one is a perfect square trinomial. Now, how does it factor? It becomes a binomial squared, and in the front you put a 3y, in the back you put a 2, and you always take the very first sign. And you can factor that quickly. You don't have to do the diamond, you don't have to do the grouping. Because you notice the pattern is a perfect square trinomial, you can immediately factor it into 3y minus 2 times 3y minus 2. Here's the next trinomial to see if it's a perfect square trinomial. The first term is a perfect square. It comes from a 5x squared. The last term is a perfect square. It comes from a 3. So now we ask ourselves, is the middle term 2 times 5x times 3? 2 times 5 is 10, times 3 is 30. Yes, it is. So we can say that the factored binomial is 5x minus 3 squared. Now that we've learned all the different kinds of factoring that we can, this page is going to be about a summary of all the different kinds of factoring of polynomials. And here's your summary. It's based on the number of terms. You always want to look at the number of terms that you have, and that will tell you what kind of factoring you should apply. First of all, you should always look for GCF. Everything is made easier by pulling out a common factor, so no matter how many terms there are, look to pull out a GCF. If there are 2 terms, you'll want to use the difference of squares technique that we learned, and that's where you have a perfect square in front, perfect square in the back, and a minus sign in the middle. If there are 3 terms, there's 3 different methods of factoring, starting with the easiest. First, perfect square trinomial, which is the one we just learned. Second of all, you hope that the leading coefficient is 1. If it is, you're going to make your diamond a lot easier. And then the last alternative is you factor it using the diamond that doesn't have a leading coefficient of 1. And so that means your number is just going to be a little more difficult. And then finally, if there's 4 or more terms, you're left with grouping. So the key to factoring is counting the number of terms and then applying the method of factoring that goes with those number of terms. Here are some different polynomials that we're going to factor using our list that we just talked about. We'll start with this one over here. Always look for a GCF, and when I look at this I notice that there is a 4 in common to both terms, so this becomes an x squared minus 9. Now I want to look at what's left over, count the number of terms, there are two of them, and the only method that we can use to solve when there are two terms is a difference of squares. So we look to see if this is a difference of squares, and it is. X squared comes from an x and an x, and 9 comes from a 3 and a 3. It's a plus and a minus, that's how you factor difference of squares, and so there's my factored polynomial. Second one, there are no GCFs, so that's out. It's not two terms, so we can't use a difference of squares. So we're going to have to use three terms. Hopefully you notice that this 6 is not a perfect square. I'll go back to my list here. So we have to rule out a perfect square trinomial. We can't use that shortcut. So we're left with the diamond. We're going to have to solve it that way. 25 times negative 6 is negative 150. We want two numbers that multiply to give us that, and that add to give us positive 5 on the bottom. Now we're going to list all the factors of 150. So here you have all the factors of 150. So I need two of these factors that multiply to give me negative 150 and add to give me a 5. Well, it looks like I'm going to work with 10 and 15, but one of them has to be negative and the sum is positive, so go negative 10, positive 15. Rewriting our trinomial now, 25x squared in front, minus 6 in the back. The middle two terms are minus 10x and plus 15x. Now we do grouping. Take out a 5x. I'm left with a 5x minus 2. Take out a positive 3, and I'm left with 5x minus 2 there as well. Now we take out the 5x minus 2, and what's left but 5x plus 3. So that polynomial factors that way.